Hello, my name is Julin. Welcome to my talk about publishing well-formed Python packages. So, shall we get started? So, what is a well-formed package, or what do we mean by saying that a package is well-formed? Well, the main objective of making a package well-formed is to make it more maintainable, to make maintenance and more easier task, so that uh, the time is not wasted on trying to fix problems that could be avoided in the first place, or at least minimized in the first place. So a maintainable code it should be easy for the developers working on it and for the users to work on the project so that it can be extendable. So we can adapt it to our changing needs as the need for the project evolves. We should be able to change it. So yeah, something like that. So what can we do to make our package well formed? Well, sufficient documentation so users know what's going on, and the developers themselves will be helped by it a lot. And a well-written test can help, along with some other related stuff. So let's take a closer look, shall we? Now, this is what I had in mind. I was talking about in this session, starting from linting and styling, through testing, all the way to packaging and publishing. So let's start with linting and styling. So in order for a code base to be maintainable, we should first be able to comprehend, read, and understand it easily. So it should be readable. The code must be written in a style and format that makes it easy to understand. It should be readable. So how can we make it readable? How can we make the code more consistent? Well, you could adopt a suitable coding style and apply some linting tools to enforce those styles and checks. So these linting tools themselves would often help you detect some subtle bugs that you may have missed while writing your code, and which can of course be helpful in fixing it before it goes into production and messes things up for us. And of course, the suggestions in PEP 8 are good to have in mind, those suggestions mentioned in PEP 8. But as PEP 8 itself suggests, it's probably better not to follow, not like that, but to not follow your coding style in a very blind manner, not to follow it literally. We should follow it within reason. We should remember that the guidelines are to help us write good code. So these are guidelines, not exactly steadfast rules which cannot be broken at all. So, for example, consider a very long link to an external website that you feel would make the code base better if you placed it in a comment, so that if someone comes and looks at your code and finds it hard to understand, they can just click on that link and go there, refer the stuff written there. So it will be helpful in understanding the code. So you want to place the link in there. But what if the link is longer and the maximum number of characters allowed per line as per the code style that you're following? Well, what would you do in such a case? Would you split the link so that into two lines so that it fits into fits into the maximum number of characters per line rule? Or would you leave it like that? I think it's probably better in such exceptional cases to make an exception to the rules suggested in the coding style that you are following. But that does not mean that you can break it nilly-willy. You should use your judgment. If you're not sure, it's always better to ask somebody who is more, who has done such kind of things before. And Python being a very friendly community with a sizable following, it shouldn't be difficult for you to find a friend who will help you out in such matters. So what kind of tools can be used? What tools can be used for doing this linting and styling? Pylint and Flakegate are some of the most prominent linting and styling tools that is used by the Python community. And both Pylint and Flakegate have got a sizable, a lot of people working on it, a lot of people who like it and who use it and would be willing to help you out if you're stuck somewhere while using it or run into any problems. And these tools are quite configurable. Meaning that they can be adapted to the coding style that you prefer to follow, so that it won't throw any false warnings related to the coding style that you follow. And Pylint has been around for a very long time. It is one of the oldest linting tools, which is still being maintained for Python. And it has quite a reputation for being or having a lot of configuration options, so much that you can easily get confused by all the options to configure the tool. But the default configuration of both Pylint and Flakegate should be a good enough starting point when you're getting started with your project. And of course, there is Black. Black is an automatic code reformatting tool which can be used to take care of the formatting part of your code base entirely. If you're using a tool like Pylint and Flakegate, you will obviously spend a lot of time running the linting tool again and again to ensure that your code is still following the coding style and nothing is amiss in between. And so if you're using a tool like Pylint or Flakegate, you will have to keep running it over and over again, and especially if you have a lot of people working together on your project, and they might not be able to follow your coding style entirely. Mistakes can creep in, and the others will be spending a lot of time trying to fix it so that all the linting checks can pass. But if you're using Black, such problems disappear, and you can focus more on your problem that is to be solved by your code rather than on the formatting of it. Because the Black takes care, but of course you should be willing to let an external tool like Black take over your coding and code formatting part. And you will have limited control over the formatting, because Black is said to be an opinionated code reformatting tool, so it will do as it seems best. So as an aside, it has limited configurability, but due to the big problem that it solves and the amount of time that this tool is able to save, a lot of big projects are using it now. Another thing that can help to make your package better is static type checking. Python had been having type annotation for quite a long time now. Making use of it not only improves the readability of your code, but by running static type checking tools by running static type checks on it, we can in a way take advantage of the of a statically typed system, along with the flexibility offered by the dynamic nature of Python. So something like that, we can combine the best of both worlds. And using type annotations would have no effect on your program. No matter your with or without type annotations, your program execution would remain the same. There will be no effect, which is an added advantage. So tools like MyPy, PyType, and PyArray can be used to perform static type checks on your code. Let's see an example of static type checking. In this example, I'm using MyPy to run static type checks. So we have a function which accepts two arguments, x and y, and it does some comparisons and returns an integer value. If x is less than y, we return a negative value, -1. If x is greater than y, we return 1, which is a positive value. And if x is equal to y, we return 0. But how are we to know what kind of values x and y are expected to be? Of course, it could be that it is willing to accept all objects which supports comparison operators, but that may not be the case. For instance, it could be two integers like this, or it could be two lists like this, or even two tuples like this, or two strings like this, among other possibilities. Well, by this function, I actually expected that x and y to be strings. But how are others to know that? How are we to know that? There's no obvious way of knowing that. Consider the same function with type annotation added. Just by looking at it, we understand it is clear that x and y are expected to be strings, and the function returns an integer value. But how do we enforce this? Using strcmp like this by passing two integers instead of two strings, Python interpreter would not complain because it sees nothing wrong in it. There won't be any errors. It will go on like that. And this may lead up to bugs later on in the code that uses strcmp function. But what if you run mypy on this? Mypy obviously supports that strcmp expected in strings but got integers. Now we can fix it, and we make those integers into strings. We run mypy again, and mypy says all is fine, it's good to go. So that was it about static type checking. Now let's come on to dead code. Dead code is something that haunts every project as it gets as time passes and the project gets bigger and evolves. Dead code can often be stay dormant without causing too much trouble, but it can sometimes interfere. It can resurrect itself and interfere with the rest of the code, the used part of the code, and it can cause some unexpected colorful results over which the developers can easily spend a lot of time banging their head on the wall without finding anything wrong. So it is desirable to remove all the dead code from your project. If you want to have all code within the code base for reference or something, you can use your version control system for that. You can look up a past commit, see how it used to look like, and decide for yourself. So we can run some checks using tools like Vultr or PyFlakes to identify that code so that they may be removed later on. Running such checks can, as I said, uncover subtle bugs due to the dead code interfering with the actual code. So let's see an example. This example I copied from Wikipedia. There's a function foo accepting two integers x and y and returning an integer which is a product of x and y. Note the presence of line 2 where a division operation is done, which has no bearing whatsoever on foo. But it won't cause any errors. It will go on. As we see past 3 and 2, we will get 6. Well, apparently it works fine. But what if we pass 0 as the value of y? We get a divide by 0 error. That dead code stayed dormant in some cases, but it comes alive in some other cases. This is not a good thing to have. So you will be able to spot this by running a tool like Vultr or PyFlakes. PyFlakes, by the way, is included in Pylon. No, for Flakegate, and yeah. So we remove that offending line, and we get the desired result, which is 0. So it is now we come to unit testing. It is important to check that after writing our code, the functions and all, it is behaving as we expect it to work. If you don't test it, it may look fine, but something may be going wrong in between, for causing those functions to return some values different from what we expect it to return. So it is always a good idea to have some test included to verify that your code is working as it should work. And organizing your code into functions that separate independently testable functions can help, but it is not mandatory. The testing frameworks and tools can help you get over that to do some better unit testing. As for the tools used for testing, there are many testing tools and frameworks available for Python. Among them is unit test. Unit test is built in Python language standard library itself, so it needs no separate installation. But also there is a third-party PyTest. I would suggest using PyTest over unit test, because PyTest is relatively straightforward, easy to use, easy to get started with, and easy even for a beginner. Let's see an example to illustrate the benefit of having your code tested. In this example, I'm using PyTest to test this code. So we have a similar function as from earlier, strcmp, which compares two strings x and y. But there is something wrong here, or is there? So I have written a test case which asserts that the chicken comes before egg in a dictionary order. So we are expecting a value of -1. But that's not the value that we get from the function strcmp. We got 1 as the value instead of -1. So what went wrong? Let's have a closer look at strcmp. What is causing it to return 1 instead of -1? Well, the problem lies here. You have used greater than instead of less than, and less than instead of greater than in these if statements. Once we fix that, like this, run the test again, and the test has passed. So we know if something got mixed up in between, and we without realizing it went on ahead. Using these tests help us realize that something was wrong before our code ever being used, before our code ever being used by somebody else. So having appropriate tests alone may not be enough. We should be ensure that our test cases cover all the relevant parts of your code which needs to be tested. Because otherwise we might as well be not having any test at all. If we are doing it, we should do it right. So that's where test coverage tools comes in. They help us spot the parts that the tests have missed, and help us identify these parts, and so that we can write more tests which cover the missed parts of your code. And though we may be tempted to have a literally 100% coverage as the way as reported by your coverage tool, it may not always be worth the effort of that you put in to have 100% coverage, because some parts of your code may not have to be tested, because it's not really useful to have tests in that case. For example, in the main part of your code, I mean the __main __, that part, we may just be having a function call. In that case, there's no point in having a test case just to cover the main part, because the main function is already covered. So the tools that we can use for coverage, for measuring test coverage, include the coverage.py, which is by far the most popular one as far as I could find, which will also generate nice HTML files showing with some good highlighting to illustrate the missed parts and all, and also offers quite a few of configuration options. And there is PyTest Core, which is a plugin for the PyTest module that I mentioned earlier, which makes use of coverage.py itself. So if you are using PyTest already and would like a closer integration with PyTest for running the coverage, you could use PyTest or PyTest Core plugin. Though it's not exactly needed, usually. So let's see another example. Oh no, actually the same example, but this time for test coverage. So we have the strcmp function which compares two strings x and y. We have the test case which compares chicken and egg. But does this cover all the cases? Does it cover strcmp completely? No. This test case compares only the condition where the x is less than y. Whereas the two other cases where x is greater than y or x equal to y are missed. They have not been tried out. So let's add those two cases as well. Oh yeah, right. Here the coverage, I had run coverage on it, and it says 3 statements were missed, as is true, and coverage is only 50%. So let's add the missing test cases. And let's run coverage again. Now it says we have not missed any statements, and we have 100% coverage. And we are happy. Let me bring this test function to your attention. As it is written now, the 3 assert statements, though we may want it to be 3 different test cases, is actually considered as a single test case by PyTest. If you want PyTest to consider each of these assert statements as a separate test case, you can use a parameterized test offered by PyTest by means of a decorator, like this. Now these parameters will be passed one by one to the strcmp function, and each of these test cases will be considered separate instead of being a single entity by PyTest. So now we have our code tested, and it works fine on your machine, on your Python environment, on your Python version and implementation. It works fine. That's good. So what if you want your package to be supported in other Python environments as well, like different Python version, different Python implementation, maybe PyPy. So we have not tested it on all these environments yet, right? So you can use a test automation tool for that, to run your test in all the different versions and maybe all the different Python implementations that you choose to support. Because in some features, for example, the while-rest operator is available only in versions greater than 3.8 or equal to 3.8 actually. So if you accidentally make use of the while-rest operator in your code without realizing it, and we need to support 3.6, you run this test automation tool, they will tell you that it works on 3.8 onwards, but doesn't on others. And you would easily be able to find the culprit here. Talks and nogs are some of the tools that you can use to perform test automation in Python. What tools like talks does is that it creates a separate virtual environment where it will install your package so that in an isolated manner, so that it will be like you have installed into a fresh Python installation. And it runs your test there and reports it. It points the outcome. Yet, talks can sometimes be confused. The PyTest can be confused in thinking that your test actually worked when it may not have worked. It has something to do with the package layout. Let's see more of it. Package layout means refers to just the way the directories and files are organized within the packages directory. There are 2 main commonly used package layouts in most Python projects, and that is the flat layout like this and the src layout. In the flat layout, the package's source code under the package name directory in this case, which in here the package name directory has all the Python files which is part of your package, and the test directory has all the tests that are used to test the functions present inside the package name inside the source code in the package name directory. Observe that the test directory and package name directory, the source code directory, are on the same level. And because of the way yeah, we'll get to that later. And we have the SRC layout, where in contrast to the flat layout, the source code is isolated from the test directory by means of an additional and nested directory. So let's see what happens in flat layout when we use docs, virtual environments. So because of the fact that both the source code directory and the test directory are in the same directory level, when you test your code with docs, instead of importing from the docs virtual environment site packages directory, the test in the test directory will import from the source code directory itself, because of the way the Python import system works, so that your code is actually running in your own environment instead of with the virtual environment in a way. And the docs thinks that the test may have passed, when in fact it may not have passed. In SRC layout, there is no such problem because the source code is hidden inside another directory, so the test cannot access the source code itself. And when it cannot find it there, it will go to the virtual environment site packages directory, and it will actually run against the installed version instead of the one that it has in the neighboring directory. So this is the reason why a lot of people have been advocating the use of SRC layout over flat layouts. But having said that, there is no officially recommended layout for your Python packages. The Python community have not yet reached a consensus on which package layout would be better and which may not be better. We can only say that we should be using the one that fits our needs better. Generally, for small packages with only a few files, the flat layout may be okay. But as the project becomes bigger and if it has any submodules, you're probably better off using an SRC layout. You can check out these links to see some interesting discussions and arguments about this subject. And going to a PyPA GitHub account, you will probably be able to turn up some very lengthy discussions which happened over a very long period of time regarding this matter. So after having our code ready, we should let the prospective users know how they can actually use our module, our new package. Proper doc strings would help, of course, and if your package is small enough, there is not too much of an API, a simple README file may be enough. But if it is bigger than that, if you need your documentation to span many pages and maybe many different sections and all, you can use a documentation generator like Sphinx and mkdocs. If it interests you, the Python documentation website docs.python.org actually is created using Sphinx. Sphinx has, I think, actually created for the Python documentation, and it prefers the use of restructured text REST, but can also handle a markdown input using our common mark package as an extension. Although in that case, you will probably be missing out on some of the more advanced features offered by the REST format. mkdocs is simple enough to use. It uses markdown, and is often, yeah, that's it. So once you have your package already, your test all good, you pass in all the environments, you may want to share your module with others so that they can also use it. So for that to happen, you first need to create a file which can be used to install your module into other systems. The process of creating such file is known as packaging in Python. Such a file may be a binary distribution like real or a source code distribution. So what tools can be used for doing this packaging process? There is setup tools by the Python Packaging Authority, which used to be almost the only tool available for quite a long time. Though newer tools like Flit and Project showed up and have taken a fair share of setup tools users. So once we have our packaged the distribution files ready after the packaging process, we can publish it to a server so that others can install your module from those servers. Commonly, we upload to the pipey.org server, but if you are publishing for the first time, you probably would benefit from uploading it first to the test.py server, which is a place which is almost exactly identical to the PyPI website, where we can try out how our package works on the PyPI server. So we can upload our project to test.py, download it from there, see if it still works, and if everything is all right, we can upload it to the real PyPI server. So how can we do the publishing part? How can we upload to another server our distribution? If you're using setup tools, you can use Twine. Actually, Twine can upload the distribution files irrespective of the tool used to build your project. Even if it was built with Python Poetry, you can still use Twine. And if you're already using Flit or Poetry, they can do the publishing part by themselves. So I mentioned a few tools so far, but they are not by no means the only tools available to help your package. Actually, there are countless tools available. Here I mention a few of them. There is bump version, which can be used to modify the version number of your package in a more easier manner. By just with a single command instead of going to all the files which mentions your version number, which is quite a convenient way of doing, changing your package's version. Then there is pre-commit, which allows us to run any commands or scripts each time before a commit happens in your repo. Then there is isort, which sorts your imports in an alphabetical manner, section-wise. Then there is cookie cutter. Cookie cutter is useful, especially useful if you're using setup tools to package your project, because setup tools requires a lot of files to be set up in order for it to be set up. And you can use a cookie cutter template to establish that file structure as like a scaffolding tool before you get started with it. Cookie cutter is by no means limited in use to Python. It is used in almost every language, and it's quite a popular tool. So where do we go next from here? The PyProject.toml file can become a center point around which your package revolves. Already the proposals 5.7 and 5.8 have paved the way for using a different build backend other than setup tools. So we can use other projects like Flit, Poetry, and Hatchery or something. And discussions are on the way on other proposals like 6.2.1 and 6.3.1 about including the project's basic metadata inside an independent section inside the toml file by project.toml file instead of being inside the packaging tools section. And also because of the need for the toml module for all the packaging stuff and the PyProject.toml file, we can probably expect a toml module to find its way to the standard library of Python before too much time passes. The toml language specification first version is not yet out. The release candidate 3, I think, is out. I have seen in discussions that the Python community is thinking of starting discussion on including a toml module once the toml language specification reaches a stable enough state and the first version is released. So let me wrap up the talk by having a quick summary of the talk. We looked at linting and styling using tools like Flake8 and Pylint. We looked at MyPy. We looked at dead code identification, testing using PyTest, among others, coverage of their test, automating test, and finally the packaging and publishing part. So that concludes the presentation. Now, if I have time, maybe I can show you a quick demo.
Okay, Julin, thank you for your presentation.
Right,
now
yes.
let's see the questions. Okay, the first question is regarding will those slides be made available? So will you share the slides after the presentation?
I will share a link in the Discord channel so you can have it.
Okay, perfect. Another question. For software development, should we use pip install editable package name before development? Scenario 1. Okay. Do the demo.
Yeah,
demo. There's the request that you should do the demo.
Okay. Well, I have not done the editable install in the demo, but I'll answer it now, I think. It would be better. Alright, okay. When you're developing your project, it is probably better to do an editable installation so that when you're making any changes to your project, the source code, you don't have to install it or build and install it over and over again. Because the editable installation is actually a link to your source code, so that would be best, I think. That is the way how it is done, actually. That's what I think. And even for if you're using a tool like Flit, there are ways to do some symbolic, installation, temporary development installation using symbolic links. It's are already there.
Okay, there are multiply requests for you to do demo.
All right, thank you.
So maybe if it won't be possible here, then maybe on Discord or somewhere else. But yeah, okay,
all right,
great. Do the demo.
Are we out of time?
Huh?
Are we out of time? Are we out of time?
No, we're not out of time. I guess we still have 10 minutes.
Then I will show the demo.
Okay.
All right. It's a short one. Faster. Yeah. So I have made a tiny project out. Project out of the strcmp file. strcmp function that we saw in the slides. So this package just has a single function that I can show you now. So this is all this package consists of. This strcmp function that I showed you earlier, along with doc strings to satisfy the linting tools. And I have the test. Oh wait, before that, I think I'm running the talks command because it will take some time to run. So yeah, we'll come back to this. It will take some time for the talks to finish running. So till it finishes running, I will show you around some files here. So that we have inside the test, the same test that we saw in the slides as a parameterized test in PyTest. Let's have a look in the docs.ini file. And I'm asking talks to run the test in Python 3.6 through 3.9 along with PyPy3. And then I'm asking it to run some vulture commands, Flake8, Pylint, MyPy, and test coverage. So talks, I've just asked talks to do all of them, and it will take some time to finish running all those tasks. So I just want to show you what's all tests were being run. Have a look at sub.py and have the package's name, version number, a description, some draw classifiers, some links, and I say that I need at least 3.6 in order for this package to be run. Then have a look at PyProject.toml file. It just says that it uses setup tools for building, and the vulture should be lenient about some names in the whitelist. The whitelist is used tell vulture, which is used to identify dead code, that this function is not really unused. It is actually being used, and as strcmp is only defined but not actually used in the function, vulture says it may be unused. So I'm just saying that it's okay to vulture, so to take care of that. So now we don't have a distribution directory, so let's build our package I'm using setup tools here. So I'm using setup tools to have a yield file and the source distribution. So see, I have now this directory shows up now, and in it I will have the wheel file and the source distribution as the tar.js file. I can actually upload this to a server using Twine, like Twine upload repository. By default it's a pypy.org server, but I want it to be test pypy for now. I'm not going to actually upload it. I have already uploaded it, so I'm asking Twine to upload all the files from this directory. So if I do this, I'll be prompted for my password, username, and the stuff. And after that, it will successfully upload it to the server. And actually, it looks like this. It shows up on the test.pypy.org server, the package name here, and you can actually install some test.pypy server using this command. So let's see if our talks tests have finished. Yeah, talks has finished. It says that the Python environment tests have passed, vulture and other tests have passed. That's it. All right, that's it. Thank you.
So, thank you very much, Julin, for your talk.
Thank you for listening. Thank you.